Hello, everyone, and welcome to the conversions and basic rates version of our GMAT Ninja Quant video series. So great to have you with us today. Before we dive into whether this video is for you and what exactly we're going to cover in this video, I want to start with a quick warning, and that is this. This is the conversions and basic rates video. And so if you're looking for questions that are going to dive into harder rates, like questions about the trains coming together, questions about one vehicle catching up to another vehicle, that will come in a separate video that we'll do on more advanced rates concepts. But in this video, we'll cover unit conversions and we'll cover the basics of rates. And so again, if you're looking for those super hard questions, although we will get to some harder questions that involve conversions and some basic rates later in this video, if you're looking for those harder advanced rates questions, we will get into those in a different video. So I want to talk about, though, whether this video is for you. And here, there's several reasons that it could be beneficial for you. The first is this, is if you take forever currently to do units conversions, then I'm going to show you in this video a very quick way to run through units conversions. Going to make it very simple for you, take out a lot of the complexity. So if you take a while to do units conversions, this video is definitely going to be beneficial for you. Secondly, if you get lost in the middle of those units conversions, you find times where if things get too complicated, your whole process falls apart. We'll take care of that in this video. If you don't know what to do when you're dealing with multiple rates working together, then we'll cover that as well. We'll talk about combining rates in this video. And then if you struggle to convert rate problems into solvable algebra, we'll cover kind of some of the basics of how do you, when you get a rate question, how do you convert that into solvable algebra. And finally, if you don't have a consistent approach to conversions or rates, we'll give you that consistent approach in this video. I also want to touch on what we'll cover. So several things that we'll cover here. Unit conversions, we'll talk about that. We'll talk about converting rates to algebra, like I said. We'll talk about combining rates. We'll touch on average speed, and we'll talk about how logic and rates can work together to help you solve problems. Now, again, I just want to warn you before we dive in here that we're not going to get into necessarily those advanced rates questions, when we talk about trains coming together, the catching up, one vehicle catching up to another vehicle, all sorts of questions like that can get super complex. We will cover in another video. So, but in this video, that's what we'll cover. And so I'd like to dive right into the first question. I'll go ahead, I'll put this question up on the screen for you. Take a moment, work through it, see if you can solve it, and then we'll come back and we'll talk about it together. And similar to some of the previous videos, we're going to start off easy in this video, and then we're going to build up to some harder questions towards the end of this video as well. So let's take a look at this first question together. Awesome. Hopefully you've had a second to work through this one. If not, go ahead and pause the video right here and we're going to go ahead and dive into the explanation. The question asks, if Paul is traveling 40 kilometers per hour, how long in minutes will it take him to travel 10 miles? And I'm told also that 1 mile is equal to 1.6 kilometers. I'm going to go ahead and we'll take a look at this one on the board together. But something that's really important right off the bat is that you have a consistent process to unit conversions. Because for a question that's simple and easy like this one, you may be able to get away with something a little bit less systematic. But we're about to get into some questions that are going to be much more difficult in just a second. And for those questions, you're definitely going to want to have a consistent approach, a consistent process. And so that's what I'm going to try and give you in this question. So what I want to do for every unit conversion is I want to do two things first. I call them step 1A and step 1B. Step 1A is I want to figure out what is it that I want to convert? What's the thing that I want to convert? What is it that I want to convert into something else? In this instance, I'm given a question where I'm given information in kilometers per hour, and then I'm asked for an answer with miles and minutes. And so what I'm going to do first is I know that I want to convert my kilometers per hour. So step 1A is this. Okay, I'm going to start here with 40 kilometers per 1 hour. And you'll notice that I write it like this, 40 kilometers over 1 hour. And that's going to be important because it's going to help me be very systematic about the way I approach this conversion. In the second step, step 1B, and again, I do these two things first, every unit conversions question. The second step is going to be this, is I'm going to think about what are my desired end units. In other words, what units do I want to end up in? And if I look at this question, sure, I want an answer in minutes, but I'm given a rate and I'm converting a rate. And so I want to convert my rate to miles per minute because, again, I'm asked about miles in minutes. And so I want to convert my rate from kilometers per hour to miles per minute. And this gives me some sort of trajectory, something to work towards. Okay, what I'm going to do now is I'm going to start this conversion. And I'm going to be very systematic about it, the way that I approach this conversion. So the first thing that I'm going to do is I've got 40 kilometers per 1 hour. Well, I want minutes in my denominator. So I'm going to go ahead and I'm going to multiply 40 kilometers per hour by 1 hour per 60 minutes. Then what I'm going to do, next step, is I know that my hours are going to cancel because I have it on the top and on the bottom of my fraction. And so I'm going to go ahead and cross those out. I also want you to think about why we can multiply by 1 hour per 60 minutes. And the reason for that is because 1 hour is equal to 60 minutes. And when the top and the bottom of my fraction are equal, I'm not actually changing the underlying value. It means I'm just changing out the units. And so that's why I multiply by 1 hour per 60 minutes, is because 1 hour is equal to 60 minutes, top and bottom of my fraction are equal. I'm not changing the underlying, in this case, speed. I'm not changing that because my top and bottom of the fraction are equal. Then what I'm going to do is I want to get out of kilometers and I want to get into miles. So again, I'm going to want miles on the top of my fraction, and I'm going to want on the bottom of my fraction kilometers so that my kilometers can cancel. And again here, what's important is that the top and the bottom of my fraction are equivalent in value, so 1 mile is equal to 1.6 kilometers because that means I'm not changing this underlying speed. From here, I can go ahead and I can cross out kilometers and kilometers. One other thing, you'll notice that I didn't right away multiply or do 40 divided by 6 because you never know where things can cancel in a question like this. And so what I'm going to do is, but now that I've got everything set up, I am going to see where things can cancel. So obviously I can cancel here a 0 here and a 0 here. In theory, you could make this 2/3, but what I notice is that 4 divided by 1.6, just because I don't love my decimal in the denominator here, is that 4 divided by 1.6. 1.6 times 2 is going to be 3.2. 1.6 times 2.5 is going to be 4. So I'm going to be able to cancel here my 1.6 and my 4 and basically change this into a 2.5. And so now what I end up with is 2.5 miles per 6 minutes. Now, that's not exactly the prettiest rate, but that's also not really a big problem, okay? And I'll explain to you why that's not a huge problem. Because now what I'm going to do is I'm going to take the fundamental formula that's at the basis of almost everything we'll do in this video, which is that distance is equal to my rate times my time. I'm looking to solve here for time. And so I'm going to say that my time is equal to my distance divided by my rate. I know that the distance that I want to travel is 10 miles. I know that my rate is 2.5 miles per 6 minutes. And again, it's not gonna end up mattering all that much that I have kind of a not pretty rate here, because when you divide by a fraction, you're going to flip and multiply. So I'll go ahead and cross this out, and instead I'm going to multiply by 6 minutes over 2.5 miles. And again, you'll notice here that the units cancel. My miles cancel with my miles. 10 divided by 2.5 is going to be 4. So 4 times 6 minutes, which is going to give me 24 minutes here. That being said, that's D. But this is just kind of gives you, and again, this is an easy question. And we went through this slower than we had to. But the reason that I want to go through it like that is because there's a systematic process to this. Remember, step 1A, step 1B. What am I starting with? What are my desired end units? And if you do those 2 steps first, then you can ultimately get to a place where you're able to do your unit conversion, fill things in, distance equals rate times time here, and you arrive at the answer 24. So D was the correct answer there. Let's go ahead, and I want to take a look at another question. Still just unit conversions, but things get a little bit more complex on this one. So let's go ahead and take a look at it together. Awesome. Hopefully you've had a second to work through this one here. We'll go ahead and talk about it together on the board. If you haven't had a chance to finish it, then go ahead and pause right here, and you can pick back up when you've had a chance to finish it. But the question asks, if 35 skips are equal to 33 hops and 66 jumps are equal to 81 skips, how many hops are in 140 jumps? So as we look at this one together on the board, I've written the question up here. And remember that for any unit conversion, and if you didn't do this, then you probably struggled on this question, but for any unit conversion, I want to go straight to step 1A and step 1B. So in this instance, I'm going to ask myself first, what is it that I want to convert into something else? Now, what am I may have even phrased it like this on the last question, what am I starting with? Now, the temptation here is to say, well, I'm starting with 35 skips per 33 hops. But that's not actually the thing that I want to convert. The thing that I want to convert here is my 140 jumps. That's my known value, is I want to convert my 140 jumps, and I want to take those 140 jumps, and then step 1b, I'm going to ask myself, what is my desired end unit? And in this case, my desired end unit is hops. I want to know how many hops are in. So I'm going to go ahead, and my desired end unit here is hops. From here, what I'm going to do is I'm going to just chart out my conversion path. Unfortunately, I can't go straight here from jumps to hops. So instead, though, I can go from jumps to skips. I see that, and then I can go from skips to hops. So what I'm going to do is I'm going to go ahead and I'm going to multiply. And remember, when I'm doing this unit conversion here, because I want to get rid of jumps, I'm going to put that on the bottom so the jumps will cancel. And I want to convert in immediately to skips, eventually to hops, but immediately to skips. So I'm going to put skips on the top. Now, like we said on the last question, I want this value on top to be equal to this value on the bottom so that we don't change our underlying, in this case, length or of a skip or a hop, right? So what I want to do is I know that 35 skips, I'm sorry, 81 skips are equal to 66 jumps. And so I'm going to do that. That's going to allow me to cancel my jumps. And I always want to cancel the units just to show myself, kind of prove to myself that the conversion is working out. From here, what I'm going to do is I've got skips on the top. And I want to get rid of the skips and I want to get into hops. So I'm going to put skips on the bottom and hops on the top. And I know from earlier in the question that 35 skips are equal to 33 hops. Now here, hopefully you listened to my advice on the last question and you didn't start multiplying things out right away, because what's going to happen is that all of a sudden things are going to start to cancel, and that's going to make your life a lot easier. So the first thing that I'm going to do here is this, is I see 33 and 66. Well, that's nice. I'm going to be able to cancel that 33 with this 66, make this 66 2. Here I see that I've got a 2 and I've got a 140, so I'm going to take my 2 out. I'm going to make my 140 70. Oh, wonderful. I've got a 70 and I've got a 35, and I'm going to take my 35 out and I'm going to change my 70 to a 2. And now all of a sudden I have 2 times 81, and I also should have done this earlier. Make sure you do this as you're working through the problems. But I am going to cancel my skips here. And so I've got 2 times 81, which is going to be 162. And obviously the only unit I'm left with is hops, so all the units work out. A lot of things canceled, which is why we say set everything up and then cancel before you multiply things out. And 162 hops, that happens to be E here. So E is the correct answer on this one. Again, key takeaway there, step 1A, step 1B, set everything up before you start to cancel or before you start to multiply things out, because oftentimes things will cancel and that will make your life a lot easier. With that in mind, I want to take a look at another one and we'll start to get into some basic rates together. Hopefully you've had a chance to work through this one. If not, you can go ahead and pause the video at this point and we'll talk through it together. The question asks, Alice, Bo, and Carrie assemble X widgets in 3, 4, and 6 minutes respectively. What is the ratio of the time it takes Alice and Bo working together at their respective constant rates to assemble X widgets to the time it takes Carrie working alone to assemble X widgets? So what I'm going to do here is that my first step is going to be to work through who's working together and who exactly and how we can kind of work out their rates together. So what I'm going to do is that first I'm going to look at Alice and Bob. And I know that the rate of Alice, who I'm going to abbreviate with an A, is X widgets per 3 minutes. And I know that the rate of Bob is X widgets per 4 minutes. I'm sorry, it's actually Bo. It's not Bob. But the rate of Bo is X widgets per 4 minutes. And also you will notice that as I put this question up here, I've abbreviated some things. Don't take that to mean that I don't want you to focus on every word that's in the question. It's just to preserve some space on the board. So make sure you focus on every word that's on the question, even if I haven't written every word that's up here. But the rate of Alice is X widgets per 3 minutes. The rate of Bob is X widgets per 4 minutes. Then the rate of Alice plus Bob is going to be, and I continue to say Bob, even though it's Bo, is going to be X widgets per 3 minutes plus X widgets per 4 minutes. And from here, I'm going to basically, all I need to do is I just need to find some sort of common denominator, right? And so when I multiply, I'm going to multiply X over 3 by 4 over 4, so I'm going to get 4X over 12 plus 3X over 12, which is 7X over 12, is the rate of Alice and Bob. Then I'm asked for the ratio of the time it takes Alice and Bo. And so for the time that it takes Alice and Bo, I'm going to go ahead and I'm going to go back to that basic formula that we used. I think in the 2 questions ago, I said distance is equal to rate times time. Here I'm going to say work is equal to rate times time. Distance is a form of work. So so what I'm going to do is I'm going to say work is equal to my rate times my time. Obviously, the work here is going to be X widgets, but I'm solving for time. So I'm going to say time is equal to work over rate. My time, my work here is going to be X widgets. My rate here is going to be over 7X over 12, right? So when I simplify, I'm going to flip things. I'm going to multiply. I'm going to multiply by 12 over 7X. My X's are going to cancel. And what's going to happen is that I'm going to get that the time that it's going to take Alice and Bo together to produce X widgets is going to be 12 over 7. And I'm asked for the ratio of that time, 12 over 7, to the time it takes Carrie to assemble X widgets. Now, fortunately for me, I'm already told Carrie assembles X widgets in 6 minutes. So what I'm going to do is I'm going to do the ratio of the time that it takes Alice and Bo, 12 over 7, over, and it takes Carrie 6 minutes. So it's going to be basically 12 over 7 times 6. Obviously, my 6 is going to cancel. And what I'm going to get is 2 over 7, which is A. So A is the correct answer here. But again, the key takeaway on this one is really when I have 2 rates, I can add, and 2 people who are working together, 2 rates that are working together, I can add those 2 rates. It's not super complicated. People tend to complicate it, but I have 1 rate is X over 3, 1 rate is X over 4. I can just add those 2 rates together when A and B are working together. And I'm oftentimes, actually always, when I'm combining these rates, going to set it up just like this: A, B, A plus B, or A, C, A plus C. However I have to do it to reinforce to myself that I'm just adding the rates when these 2 are working together. And so that's how that one's going to work. Like I said, A is going to be the correct answer. This is, again, this is not a super complex problem, but there are some basics in here that are worth becoming acquainted with and becoming familiar with. And this is something that could appear on the GMAT. Again, not necessarily the hardest type of question that you're going to see, but one that you could see on your test. With that in mind, let's go ahead and let's take a look at the next one together. Awesome. Hopefully you've had a second to work through that one. We'll go ahead and take a look at this together. If you haven't had a chance to work through it in its entirety, go ahead and pause at this point. But the question says, a pump fills an entire bucket with water at a rate of 60 gallons per hour. The same pump then drains the entire bucket at a rate of 40 gallons per hour. If draining the bucket takes 45 minutes longer than filling the bucket, how many gallons can the bucket hold? So when we look at this one together at the board, the first thing that we kind of have to do is sort out the information that we're given. So first I'm told, and again, I use shorthand here, which is not to say that every word doesn't matter, because even here I wrote a bucket when the fact that it's the entire bucket does end up mattering for the. So again, you need to be careful, as we've talked about in previous videos, to pay attention to every word of a given question. But I'm told that the pump fills the entire bucket at a rate of 60 gallons per hour. So I know essentially that 60 gallons per hour times the time that it takes to fill the bucket is going to be equal to the, and again, I could use any variable that I want. I'm going to say X here for the total number of gallons in the bucket. Okay. And I might as well go ahead and denote as well that X is equal to the gallons in my bucket. From here, I also know about what it takes to drain the entire bucket. And I'm told that the entire bucket is drained at a rate of 40 gallons per hour. But I know that the draining takes 45 minutes longer than the filling. And so here, I'm going to say 40 times my time plus, now here's where a lot of people will go wrong, is they'll say T plus 45. You can't do that because remember, this is 40 gallons per hour. And so I need to keep everything in hours. And so I'm going to say 40 times T plus 45 minutes is 3/4 of an hour. So 3/4. And I know that that is also equal to X. Well, what I can do here now is that I have two equations, and I can set these two equal to each other. And I can say that 60t is going to be equal to 40t plus 3/4 of 40 is going to be 30. From here, I know that 20t is equal to 30. T is equal to 30 over 20, which is 3 over 2, which is 1.5. And now all of a sudden, if I know that my time is equal to 1.5, I can go back, plug this in, one of my previous equations where I said that X, the number of gallons in the bucket, is equal to 60 times my time, which is 1.5. 60 times 1.5, 60 times 3 over 2 is going to be 90. And so X is equal to 90. The bucket can hold 90 gallons. And so the correct answer here is going to be B. So again, key takeaways here is this type of question can be kind of overwhelming, but good first step, translate the information that you're given, go ahead and chart it out, kind of like I did here. And then obviously you can set these two equal to each other, which is a common thing to be aware of, is that oftentimes on these rates questions, you'll get two different formulas and they both can be made equal to each other. Solve for what you can know and go from there. But some good takeaways on that one. What I want to do, and again, we're still working through some basic rates, although there is some complexity to that. We haven't gotten to super hard questions yet, but these are the type of question that you could see pop up on your test. And a lot of people end up struggling with these type of questions because they just get overwhelmed by what the question's asking for. So let's go ahead and we'll take a look at another one. I'll pop it up on the screen, take a moment to work through it, and then we'll come back and talk about it together. All right, so let's take a look at this one together. The question asks, it says, to qualify for a race, a runner must run 400 meters at an average speed of 8 meters per second. If Wade ran the first quarter of his 400-meter race at 10 meters per second, what average speed in meters per second must Wade maintain for the final 3 quarters of the race in order to qualify? So this is the first question where we're getting into average speed here. And one thing to be aware of with average speed is that it's a little bit counterintuitive. And at times people can run into some challenges when they try and just use simple intuition to solve this sort of thing. For example, common sort of question that you'll see is, if we had said Wade ran the first half of a marathon at 8 meters per second and the second half of the marathon at 10 meters per second, which would be a really fast marathon, then what would his average speed be? A lot of people would jump straight to 9 meters per second, but you can't just average the two because that's not the way that average speed works. And we'll get into that in just a little bit here. But let's go ahead and we'll start to work through this here. So we know that to qualify for this race, that the runner must run with an average speed of 8 meters per second. Now, average speed is going to be equal to the total distance divided by the total time. And so I know that Wade ran the first quarter of his 400 meters at 10 meters per second. So I can start. I know that I want my average speed to be equal to 8. And that should be equal to the total distance, which is 400, divided by the total time. Now, here's what I know, is that the time, distance is equal to rate times time. Time then is equal to distance divided by rate. The time for the first 100 meters is going to be 100. for the distance divided by the rate of 10. So in other words, the time for the first portion is going to be 10 seconds here. So on the bottom of my fraction here, I'm going to do 10 seconds plus, and what I'm going to do here is I'm going to call this t sub 2, just so I remember this is the time of the second portion of the marathon, the last 3/4, is going to be equal to 8. What I'm going to do is I'm going to go ahead and I'm going to start to solve here. And what I find is this, so I'll multiply both sides by 10 plus t sub 2, which is going to give me 80 plus 8t sub 2 is equal to 400. Then 8t sub 2 is equal to 400 minus 80, which is going to be 320. And 320 divided by 8 is going to give me my time of how much time I spent on the second portion of the marathon, which again is not the second half of the marathon. So 320 over 8, obviously 32 over 8 is going to be 4, so 320 over 8 is going to be 40, is the time of the second half of the marathon. Now again, I know that distance is equal to rate times time. I'm trying to solve for the rate here, so I'm going to say that my rate, my r sub 2, my second rate, is equal to my second distance over my second time. My second distance is the final 3/4, so that's 300 meters. My second time is going to be 40 seconds. And what I can do here is I can start to cancel, right? Cancel a 0. 30 divided by 4, 28 is 7 times 4 is going to give me 28. So 7.5 times 4 is going to give me 40. And I'm sorry, 7.5 times 4 is going to give me 30. And so my second rate is going to be equal to 7.5. And obviously that's D here, so D is the correct answer. But good takeaways here. Number one, average speed isn't always as simple as it appears. A lot of people think, oh, just, I can just say 10 meters per second and 6 meters per second, and it'll average out to be 8 meters per second, right? That's not actually the way that it works, right? Even if it was first half of the race, 10, even if it wasn't 1/4, then 3/4, even if it was, first half of the race, then second half of the race, you still couldn't do 10 meters per second for the first half of the race and 6 meters per second for the second half of the race, and that averages out to 8 meters per second. That's not the way it works, because average speed is about the amount of the total distance over total time. And so you actually, if you were doing 2 halves of a race and you did 1 half at 10 meters per second, 1 half at 6 meters per second, you actually end up spending more time running at 6 meters per second because you're running slower. And so that's weighted a little bit more when you do average speed. But just stick to the formula, stick to the equation here. Start to fill out the equation, which is where a lot of people run astray on these rate problems or on conversion problems, is that they get overwhelmed. Stick to what I know, to the equation, work through things diligently here, and I'm able to solve and find that D is the correct answer. With that in mind, I want to go ahead and we'll take a look at another one together. And we're going to start to get into some data sufficiency, and we're also going to start to get into some harder questions here that are a little bit more challenging. So we'll go ahead and take a look, take a second, try and work through this one. All right, hopefully you've had a second to work through this one here, and we'll go ahead and talk about it together. The question says, hose fills half a bucket in 16 minutes. Can the bucket hold 8 gallons? And I'm told that 1 gallon is equal to 128 ounces. Then statement 1 tells me the hose poured more than 1,900 ounces per hour. Statement 2 tells me the hose poured less than 2,000 ounces per hour. Let's go ahead and take a look at this one together on the board. So this is state of sufficiency. I'm going to go ahead and write for myself AD over BCE here. And one thing that I'm going to keep in mind as I look at this question is I'm always thinking about what's the most efficient way to do things. And one reason that we always recommend for students to read the whole question first, to read the entirety of the question from the get-go, even on data sufficiency and not just jump right into statement 1, is one thing I notice here is that both statements give me information in ounces per hour. And then the question gives me information in gallons per minute. Now, what happens for a lot of students is that on a question like this, they end up starting to run out of time. They feel time pressure. The time pressure gets to them. They just abandon ship on a question like this. And the reason that happens so frequently is because oftentimes students will jump to, well, let me convert this to gallons per minute. Let me convert this to gallons per minute. And then let me see how I can work through that. But again, on this particular question, why not just do the 1 conversion from gallons per minute to ounces per hour, then do 2 conversions from ounces per hour to gallons per minute? It just doesn't make that much sense to do it that way. So instead, what I'm going to do is I'm going to start by converting my information, which is given to me in gallons and minutes, to ounces per hour, and then see if I can get anywhere from there. So I'm told that the hose fills half a bucket in 16 minutes. And again, I want to make sure I pick up on the half a bucket in 16 minutes. That's why it's important that you read the whole question, read it twice, plot your path forward, check each step as you go, read the question one more time at the end. And we covered those in a previous video, but hopefully you're still doing those at this stage as well. But a hose fills half a bucket in 16 minutes. So a hose fills the entirety of the bucket in 32 minutes. And then I also know I'm asked whether the bucket can hold 8 gallons. Then I'm given information on the rate of the hose. But basically, what the question's really asking me is the rate of the hose greater than 8 gallons per 32 minutes? That's really because, again, I'm being asked if I know that in 32 minutes that the entire hose will be filled. So if the rate is greater than 8 gallons per 32 minutes, then the bucket can hold 8 gallons. It can hold more than 8 gallons. It actually, technically, I should say, is the rate greater than or equal to 8 gallons per 32 minutes. And then what I'm going to do here is I'm going to start to convert things. And just like I've done on previous questions, I'm going to set up my whole conversion. I've got step 1A here, which is what am I starting with? And then I'm going to do step 1B. What do I want to end up in? In this case, I want to end up in ounces per hour. And then I'm just going to start to work through my conversion. We covered how to do this in a previous question, but I'm going to put on the bottom 1 gallon. On the top here, I'm going to put 128 ounces. Then I'm going to multiply by 60 minutes over 1 hour. And from here, I'm going to start to cancel things, and my life is hopefully going to become easier as I do that. For me, I could cancel my 8 with my 32, but instead, I'm actually going to go ahead and I'm going to, for my own sake, because I'd rather get rid of this 128. I don't like the way my 128 feels. So I'm going to go ahead and say 32 times 4 is equal to 128. So I'm going to cancel here. And then obviously I'm going to cancel my units as well. My minutes are out. My gallons are out as well. And so I have 4 times 8 times 60 here. Okay. There's a few different ways that I could do this, but basically the way that I'm going to think about this is I'm going to do 8 times 60 is going to be 480, right? Then 480 times 4, a little bit less than 500 times 4, right? 500 times 4 is going to be 2,000. 480 times 4 is going to be 1,920. And so that's 1,920 ounces per hour. And so again, my question becomes, is my rate greater than or equal to 1,920 ounces per hour? You can see I did a lot to push the question here. And again, that's my question. I did a lot to push the question here, but now all of a sudden the statements are really easy for me. So when I look at these two statements, the host poured more than 1,900 ounces per hour. Okay, but it could be 1910, it could be 1901, so I still don't know, so I'm going to eliminate A and D. The host poured less than 2,000 ounces per hour. Okay, but it still could be 1930, it could be something much larger than that. So, not larger than 2,000. So ultimately what I know is that the rate, that helps me eliminate B, and then what I know is that the rate is between 2,000 and 1,900, but obviously it could still be less than or greater than or equal to 1920 ounces per hour. So I don't actually know, even with these two statements together, whether the bucket can hold 8 gallons. One thing real quickly, a lot of people will jump to on a question like this, and the correct answer here is E, right? Those statements together aren't sufficient. The correct answer here is E. A lot of people on this type of question will jump straight to E and be like, well, it just gave me inequalities. So I know because I just have inequalities, it's E. But that's not actually the case, right? If this says the whole host poured less than 1910 ounces per hour, well, that actually would be sufficient because then I would know it's not greater than or equal to 1920. Or if this says the host poured more than 1930 ounces per hour or 1950, right? That would be sufficient. So just because I have an inequality doesn't mean that it's not sufficient here. But in this case, it does happen. It does play out that E is the correct answer and both statements together are not sufficient. Let's go ahead and again, we're kind of getting into more GMAT-like, more difficult questions here, where these are, the type of challenging questions that you could start to see on the GMAT. And so what I want to do here is I want to take a look at another one together, another data sufficiency one. And we'll give you a second to work through that. After you've worked through it, then we'll take a moment and we'll talk through it together. Awesome. Hopefully you've had a second to work through this one. If you have not, go ahead and pause the video at this point and take a second to finish it. The question asks, Paul, running at a constant pace, completed part of a marathon in 2 hours. Pete, running at a constant pace, completed the remainder of the marathon in 3 hours. How long would it take Paul alone, running at his constant pace, to complete the marathon, a marathon being 26.2 miles. So when I look at these two statements, the first statement tells me that Pete ran 4 times as far in 3 hours as Paul did in 2 hours. And the second part tells me that Pete ran 20.96 miles. When we look at this one together on the board, this is actually one where logic is going to help me a ton. Using some logic is going to help me a ton. And if I dive straight into formulas, things get really complicated. So I'm going to want to use a logical approach throughout here. Now, What I'm told is this, is that Paul ran part of a marathon in 2 hours. Pete ran part of a marathon, the rest of the marathon in 3 hours. I'm asked how long it would take Paul alone to complete the marathon. So basically, if I can find some sort of rate for Paul, that's what I'm asked for. Because if I can find a rate for Paul, then I'll know how long it would take him to complete the marathon. So when I kind of push the question, it's a lot more simple. What I'm told from statement one is this, is that Pete ran 4 times as far in 3 hours as Paul did in 2 hours. Well, so if Pete in his portion ran 4 times as far as Paul did, then basically Pete's distance is, we could call it 4 times the distance of Paul, and Paul's distance is just D. Now, what I know is that these two together ran an entire marathon. So 5D, 5 times the distance, is going to be equal to 26.2. From there, I can solve for D. And because this is data sufficiency, and this is where I say, like, some logic can help you here. Because this is data sufficiency, I really don't have to, I don't have to solve this. I know it's going to be 5-ish. And this is legitimately how I do it on the test. 5-ish is the distance that I'm going to solve for. Well, and if I know that Paul ran 5-ish, 5 something, 5 point something here, I think it's 5.24 is what it would work out to be. But because I know I could figure out the distance, that distance is how far Paul ran. If I know the distance that Paul ran, and I know the time that Paul ran, because he ran 2 hours, then all of a sudden I can figure out his rate. If I can figure out his rate, then I can figure out how long it would take him running at his constant pace to complete the marathon. So statement one is actually going to be sufficient, and I can eliminate B, C, and E. And you can see here, I didn't do a ton of math. And that's intentional because I don't want to do a ton of math. I just want to know whether it's sufficient. Statement two tells me Pete ran 20.96 miles. Obviously, I can figure out that then the remaining 5.24 miles were run by Paul. If Paul ran 5.24 miles in 2 hours, I can figure out his rate. And again, that's going to be sufficient. So the reason that we like to go through this question is because it looks really intimidating, but when you get into it and when you use algebra and some logic, rather than just jumping straight into a bunch of formulas, it becomes a lot easier and you're actually able to solve it without much stress at all. And so the correct answer here is going to be D. Both statements are sufficient, and you can see how logic there. Don't throw your logic out the window when you get to rates. Continue to integrate that into your reasoning. With that in mind, let's go ahead and take a look at another one. We've got 2 more, and these next 2 are both great questions that are very GMAT-y, very GMAT-like, challenging questions as well. And so don't freak out if you struggle with them and you're just trying to score in the 47 range. These we're kind of getting into the 48 to 50 to 51 range on these questions that you're going to see next. So let's go ahead and take a look at a couple of these together. Awesome. Hopefully you've had a second to work through this one. If not, you can go ahead and pause the video right here, but we'll go ahead and dive in. The question states chefs X, Y, and Z make one pita in A, B, and 6 minutes respectively. If A is less than B is less than 30, can chefs X, Y, and Z working together at their respective constant rates make at least 60 pitas in 1 hour? Statement 1 tells me A is less than 1.25, and statement 2 tells me B is greater than 25. We'll go ahead and take a look at this one together on the board. And again, this is one where logic is going to come into play and work in your favor. So the first thing I'm going to notice is I already know the rate of Chef Z, and Chef Z makes one pita in 6 minutes. If Chef Z makes one pita per 6 minutes, that means the rate of Z is 1/6. And in 60 minutes, your work is going to be equal to your rate times your time. So 1/6 times 60 is going to be 10 pitas. So really my question is whether A and B together are able to have a combined rate of A and B together that is going to be equal to 50 pitas per what is going to be a total of 60 minutes, right? So 5/6 pitas per minute. Now, the other thing I'm going to keep in mind is I also do have this constraint where B and A are both less than 30, which is going to actually kind of affect this because it doesn't actually have to be, there's some additional information there that's going to come into play that's going to be super important. So I'm going to keep that in mind as well. But what I'm told is that A is less than 1.25, right? The number of minutes that it takes, and I'm sorry, I've been saying chef A and B, and I really should say chefs X and Y, not chefs A and B. So the rate of chefs X and Y. But what that tells me is that the rate of chef X is at least 1/1.25, right? And then I know that the rate of chef Y is at least 1/30, because of course, if A is even smaller than 1.25, then that's just going to make this rate even bigger, right? Make the denominator smaller, make the overall value bigger, right? Same thing with the rate of B. So I know that at least these two rates together, basically what I'm told is that at least the rate of, so 1/1.25 is going to be a rate of 4/5 plus 1/30. When I start to combine these two together, of course, I'm just going to multiply this by 6/6. And what I find is that I'm going to have 24 plus 1 over 30, which is really equal to 25/30. And actually, that tells me 25/30, of course, is equal to 5/6, which means that my rate is at least 5/6. 5 pitas per 6 minutes, which is exactly what the question was asking me, is the rate of X and Y at least 5 pitas per 6 minutes? So for that reason, I can go ahead and I can eliminate B, C, and E because statement 1 by itself is sufficient. Then I start to look at statement 2. Statement 2 tells me that B is greater than 25. So in other words, chef Y takes at least 25 minutes to make a pita. Well, okay, that's great. So basically what that tells me is that if B is greater than 125, that kind of narrows down the range of B. So the time that it could take chef Y to make a pita could be anywhere from 25 minutes to 30 minutes. But again, I have no information there about A. In fact, chef X could make one pita in 30 seconds or in 1 second, in which case I would have way more than 60 pitas, at least 60 pitas in 1 hour. Or chef X could be right up there by 30 with Chef Y. Chef X and Chef Y could be right up by 30. Obviously, they can't take 30 minutes exactly, but they could be right up by 30, in which case those two together are only going to make about 4, or a little over 4 pitas in an hour. So for that reason, statement 2 is actually not sufficient, and the correct answer here is going to be A. Let's go ahead and let's take a look at one more together. This is a great question, again, because it's got kind of a little bit of a logic element to it. Number 2, because it's got the piece about 30 minutes, which, as you can see, comes up really important here, because I know the rate of Chef Y is at least 1 over 30. And then there's some logic that comes into play as well, thinking about the maximum rate, the minimum rate, right? The minimum rate is 1 over 1.25. It could even be 1 over 1. It could be 1 over 0.5, right? But it's at least that and at least that, which means the rate of the two combined is at least 5 over 6, which will give me 60 pitas at least in 1 hour. With that in mind, I want to take a look at one more. This last one is going to be complex. It's going to be challenging, intentionally so. So don't freak out if you struggle with it. You're meant to struggle with it. If you don't struggle with it, congrats, because it is a hard question, and it is one that's meant to be challenging. But we'll take a look at it, then we'll talk through it together. Awesome. Hopefully you've had a second to work through this one, and we'll go ahead and we'll start to talk about it together. But the question says this. It says oven A takes 5 hours longer than oven B to bake Y pizzas. If oven A and oven B working together at their respective constant rates can bake 3Y over 2 pizzas in 2 hours, approximately how long in minutes does it take oven B to bake Y pizzas? So if you're like me, when you first see this question, it can be a little bit overwhelming. You look at it, there's all sorts of variables. There's not a whole lot of concrete information, but that's a good time to be disciplined and to approach things in a pretty systematic way. And so that's what we're going to do here. Again, I've abbreviated this question as I've written it up on the board to save space so that we can work through this together. But every word of the question is important. And so make sure you don't fall into the habit of necessarily doing that yourself. What I'm going to do is I'm going to start with this. I'm told that oven A takes 5 hours longer than oven B to bake Y pizzas. So what I could say is I've got the rate of A, I've got the rate of B, and then I've got the rate of A and B combined. And so what I know is that oven A takes 5 hours longer than oven B to bake Y pizza. So basically, oven B can do Y pizzas per T hours. Oven A can do Y pizzas per T plus 5 hours. And then I'm told oven A and B together can bake 3Y over 2 pizzas in 2 hours. So their rate is 3Y over 2 per 2 hours. Or to simplify this a bit further, I could say that's equal to 3Y pizzas per 4 hours. And my question is approximately how long in minutes does it take oven B to bake Y pizzas? And so what I know here is this, is that I've got a rate for A and B together, and I've got a rate for A, I've got a rate for B. Well, what I should be able to say is this, is that A, which is y over t plus 5, plus the rate of B, which is y over t, should be equal to 3y over 4. Of course, these are pizzas per hour. What I'm going to do here is this, is I'm going to start to solve this and just see where it takes me, right? I don't always on the GMAT know exactly how I'm going to get to the answer, you know, from step 1 through step 9, right? But I can start to see, you know, maybe things could start to work out for me here. So what I'm going to do is I'm going to get myself a common denominator, right? So I'm going to have yt plus, and then I'm going to multiply this fraction. The whole thing's going to be over t times t plus 5, right? But I'm going to multiply this side by yt t plus 5, so yt plus 5y, and that's equal to, again, 3y over 4. Now, one beautiful thing that I notice right here is that I have a y in every term. That's wonderful, because basically on this side, I can factor out a y, and then my y's on both sides are going to cancel. And so I can cross out my y here, I can cross out my y here, I can cross out my y here, and I can cross out my y here. And all of a sudden, things on the GMAT have a tendency to work out. Things are looking a lot better for me. So on this side, though, I'm still going to have, in the numerator, I'm going to have, because I have yt plus yt, I'm going to have 2t plus 5. And then I'm going to multiply, I'm going to cross multiply, so I'm going to have 4 times 2t plus 5. On my right side, I'm going to multiply my t times t plus 5, and what I'm going to get is I'm going to have 3t times t plus 5. From here, what I'm going to do is I'm going to start to distribute. So I've got 8t plus 20 is going to be equal to 3t squared plus 15t. I'm going to go ahead and I'm going to erase some of what I've done above just to give myself some room up here to solve. And what I'm going to find is this, is that I can say that 0 is equal to, and I'm going to subtract 8t plus 20 from both sides. So 0 is equal to 3t squared. And then I'm going to have minus 8t, so I'm going to have plus 7t minus 20. And then from here, I'm going to start to factor. And I can say that 3t, and I know that I'm going to have a plus and a minus. In theory, it could be like 3t over 2 and then 2t over here. But generally on the GMAT, I know things have a tendency to work out. So I'm not gonna freak out quite yet or worry about things quite yet. I know that I'm gonna have a 3t and a t, and then I'm gonna think about, okay, what's gonna give me, how am I going to be able to multiply things that are going to give me 20 at the same time they're going to give me, I'm going to get a difference of 7 in there. So I'm going to think about some of the different factors of 20, right? Of course, I could do 5 and 4. But of course here, if I look at it, if I've got 5 and 4, then 5 times 3t, that's going to give me 15t, but minus the 14. No, that's not going to work. But I do like the idea of, if I flip this, and again, this is some complex factoring. This is about as bad a factoring as you're going to see on the GMAT. I can see that if I did 4 here, I did t plus 4 there, and I did 3t minus 5 here, then when I factor this out, I'm going to get 3t squared plus 12t minus 5t minus 20, and so things actually are going to work out there. So this is great. Now I factored, I can say that that's equal to 0. From here, what I can do is, obviously t is not going to be negative 4. You can't have negative 4 as your time. So if I say that 3t minus 5 is equal to 0, then I can say 3t is equal to 5 T then is going to be equal to 5/3, right? If T is equal to 5/3, now this is why generally you don't want to erase your work. You want to keep your work kind of organized, but I'll go ahead and write back up here what I had, the rate of A, the rate of B, and the rate of A plus B. And if you remember, I said that the rate of B was Y pizzas per T hours, and that the rate of A was Y pizzas per T plus 5 hours. Well, here, T is the time that it takes oven B to bake Y pizzas. You can see Y pizzas per T hours. And so if I know that T is equal to 5/3, I could even solve this making my work equal to rate times time. My work is Y pizzas. My rate is Y over 5/3 times my time. And when I start to solve this, obviously my Y's are going to cancel on each side. And what's going to happen is that so my Y's are going to cancel. This is going to end up being 3/5 T is equal to 1, which means T is equal to 5/3. Again, I solved for that here, and I could have just gone, I just wanted to show you that it works out in work equals rate times time form. And if my time is equal to 5/3, then I can say that 5/3 of 60 minutes, right? I'm going to multiply that by 60 just to get my time into minutes. And that's going to be 20 times 5. It's going to be 100, which is C. And so as you can see there, even a complex rate problem like this, as long as you're systematic and trust the process and trust that things on the GMAT are going to work out, it can work out for you. You don't run into too many difficulties. You don't run into too many troubles. And things have the tendency on the GMAT to work out. You've just got to be systematic. Remember how to add rates. Take it one step at a time. Make sure you track your work. Don't make careless mistakes. But again, that's a really hard question. So if you struggled with it, don't worry. It's a hard question. That's a 48 to 51 level question, maybe, on the upper side of that even. But I hope in total that this video was helpful to you. Remember, we'll have another video later on that will come out that will cover more advanced rate topics, but this was to cover basic rates and conversions. Hopefully you saw how to be systematic about unit conversions so that you won't run into trouble there in the future. Hopefully you also are able to see how you can combine rates, how you can add rates together. Remember to keep your work organized. Remember to keep your logical brain turned on. And hopefully this has been helpful to you. Remember to tune in the future to our future videos. And again, like I said, I hope that this has been helpful to you and will serve you well throughout the rest of your GMAT journey.